Good afternoon, everyone, and welcome to our last session in this BIM webinar series that we've run for the last 4 weeks, which has been amazingly well attended. So thank you all for coming along each week, or if you've dipped in and out, thanks for coming along. Before I even start, the first thing I want to do is thank Jancy George for organising it, coming up with the idea, doing all the organisation and doing all the management, getting every speaker on board. Really appreciate the work she's put in to get this webinar up and running and to get huge numbers each week coming to it. So that's the first thing I want to do. Second thing I want to do is we have a lot of speakers today, more than we've had on other days. That's why we've started a little bit early. If you have questions as we go through, please put them in the Q&A box and we will respond either throughout the presentations as people finish up. They may fill in some answers, or we'll do a few at the end of the session. Aim, as always, is to get it closed out before 2 o'clock so that everybody can get back to their lovely jobs for the afternoon. So first, today we have 3 slightly different topics that we're going to cover. The first one is BIM in the water industry. And we have Michael Kenna and Harlan Dunn from Murphy's that will give us an indication of how they're involving BIM in their industry. The next one is from Esri, where we have Padraig and Chris, who will give an indication of how BIM and GIS are integrated in infrastructure and asset management. And finally, we'll have Emma Hayes from TUD, who will outline some training that's available in BIM. And it's a nice way to close out this 4-week seminar, so you can see how you can bring it forward over the next year. So I'm going to hand you directly over to Michael from Murphy's, who will give the first presentation. Michael?
Okay, thanks, Joe.
You can turn on your camera as well if you want.
I'll share my
screen. Turn mine off.
Okay, so that's everybody can see
that's perfect. Yep, that's perfect.
Okay. Afternoon, everyone, and thanks to Jancy, Engineers Ireland, for inviting us to this opportunity to share our BIM journey over the last few years. So my name is Michael Kenna, and I'm the BIM and CAD team manager here in the Dublin office, and my colleague Harlan Dunn is here with me today to do a few of the slides also. So just by way of introduction, just a bit of an introduction to Murphy's, what we do, and our overall BIM journey then over the last few years. Some information from the projects that we've worked on, and future innovations, what we're kind of looking at to improve ourselves, and just currently where we are now. So I've been working with Murphy's for about 6 years, and been in the water industry for about 13 years, specifically BIM related activities for about 10, and went back to college. Emma's going to probably talk about it later, some of the courses that are available, so there's plenty out there for people to upskill. Murphy's themselves are an engineering and construction contractor. We're a head office based in London. We were founded in 1951 by Irishman John Murphy. We're a family-owned business, and we're currently celebrating 75 years in business. The Irish side of the business was founded in 1968, and while we operate primarily in the UK and Ireland, we do have business divisions in Canada, US, and recently in Australia. We currently employ around 4,000 people in the UK and about 1,000 people here in Ireland, and due to the growth in the water industry, where numbers are going up all the time. Murphy's operate in different divisions. You can see on the screen there, transport, so a lot of rail works, a lot of rail projects in the UK. Power, natural resources, and then water, which is what we're looking at today. So, myself and Harlan both work in the water business unit here within the Murphy Group, and we are involved in the design and build and operation of water treatment plants. So this involves all aspects of the design of the water treatment plant. We have in-house process teams who design the process treatment of the water. We have our own mechanical and electrical and automation team here as well. We also provide operational teams to a number of plants throughout the country. Our projects include water and wastewater treatment plants, and we also have projects where anaerobic digestion and biogas generation projects. Specifically from a BIM point of view, we moved to kind of BIM 3D modeling about 6 years ago. Initially, this was the creation of 3D models just purely from a coordination point of view. We also have an in-house fabrication team, mechanical fabrication team, who have been using Inventor 3D modeling since 2008, but have been doing 3D modeling from as far back as 1998, so a lot of in-house experience in 3D modeling. So our first kind of foray into kind of BIM and 3D modeling was in 2020. Prior to that, we were using regular 2D CAD and generally working in a silo, uncoordinated kind of environment. In 2020, we started using Revit almost out of a necessity. We had a large project in Huddersfield in the UK that coincided with COVID, and our teams couldn't travel to site. So coordination and collaboration became a critical issue of trying to deliver the project. The project still continued despite working on it during COVID. So having our teams working in kind of a collaborative environment was critical. A lot of people that worked on the project have never even set foot on site. There was no specific requirements from a BIM point of view from the client, so some of the work was still uncoordinated. We really kind of went down the route of BIM because of some of our subcontractors on the site. They were using 3D modeling, point cloud scanning, that type of workflow. So once we started, we saw the benefits straight away. So that kind of brought us to the point where we kind of decided that BIM implementation was kind of the route we wanted to go. And how were we going to do that? So as part of the overall Murphy group, some of our colleagues in the UK had already been down the BIM implementation route. So they had already items like ACONX, common data environments. They were preset. So we were working under some of their guidance as well. So things like naming conventions, use of the CDE, how that all worked. Previously, a lot of our guys had worked on all kind of server systems, again, like I said, in a siloed environment. What kind of standards we were working to, and how they impacted what we were already doing. We had to upskill people to realize that we were now working within a model, the different softwares, different BIM terminology that we were using, and explaining the different terminology and what it all meant. So once we were down the route, we were still using some of our old AutoCAD skills. Still used to produce some of our drawings, specifically our process and instrumentation diagrams. Arlene will speak about the changes that we made in that area a bit later on. Revit became our default 3D modeling software to produce all our mechanical type drawings. And most of the CAD and BIM team here did upskill. A lot of the guys went back to third level education to complete some of the courses that are available. So out of the use of Navis, we then had out of the use of Revit, we then had our Navisworks. Models were exported into Navis, and that allowed project teams to be familiar then with what was going on inside the models. We did have to carry out a lot of lunch and learn type scenarios to kind of upskill a lot of the different projects teams who hadn't really worked in kind of any 3D environment previous to that. Our first real BIM project then came in 2021. Our client was EngineersIreland, and we completed a project. It was known as the phosphorus removal project as part of the Ringsend Wastewater treatment plant. Ringsend is the largest wastewater treatment plant in the country, and catered for about 40% of the wastewater produced in the country, and major upgrades gone on there in the last few years. Previously catered for a population of about 1.5 million, and by the time all the upgrades are completed, capacity will be up to about 2.5 million people. So the project came with specific BIM requirements, and they were contractual requirements. It wasn't something that, like previous slides, where it was a kind of a nice to have. This was actually a contractual requirement from the client. So all our models had to be developed in Revit. So they were project information models. We had to coordinate them with the existing models that were supplied by the client. We had to make sure all our naming conventions were complying with the relevant standards. We also had Uniclass requirement from the client that model elements had to have Uniclass codes applied, and that also fed into the COBie deliverable that was requested by the client. So I'm not sure if people are familiar with COBie, but it's a standard way of organizing and delivering asset information. All this information was transferred to the client through regular data drops. The data drops were, again, contractual requirements submitted to the clients at regular intervals throughout the contract, and then a major data drop at the end of the contract, which included all the files from the project and the asset register, which listed all the assets that were part of the project. So as I say, our models had to be coordinated and well organized. So we created discipline-specific models, specifically mechanical, electrical, structural type models. So on the slides here, you can see a couple of images from one of the main mechanical models on the project. A lot of different pipe systems that we had to create, incorporate a lot of different Revit families. So the different color pipes were part of how we organized our work. So different colors represented different types of fluid that were part of the overall process. We had to include Revit families that were either supplied by suppliers or created in-house. The large tank in the middle of the slide on the right was a supplier model. Didn't initially come as a Revit file, but we got it into a Revit family. And the stairs on the left, as I mentioned earlier, we've got our own in-house fabrication team, so that's what came from the in-house team there. As I was saying, our information had to be well organized, so we created our different pipe systems that were part of the overall project, and you can see the part of the snip on the right how we named or incorporated our naming conventions, MPE being the abbreviation for ourselves, pipe system, and then the type of system it was. This naming convention also fed into a lot of our outputs, specifically our COBie output sheets. Again, similar slide to the last one. Our COBie was the requirement. As I said, everything had to be well organized. So in this instance here, we can see the pump in the image. We followed the naming convention that was specified in one of the British standards, 8541. So source, type, and subtype. So source being ourselves, type being the mechanical equipment, and subtype being the pump. We can also see the COBie properties highlighted here in the slide. Items like installation date were a requirement from the client, P&ID number, the COBie space name, and we had specific parameters that were specified by the client that we had to incorporate into all our models. So specifically, the COBie component name was one where it brought together a number of the different properties as part of that Revit element. So all our information was outputted then into the specific COBie sheet as required as part of the contract. So the COBie sheet is the little snip on the top right. Within Revit itself, we had various different schedules created specifically for check-in purposes. So checking the information that was in the model prior to outputting the COBie sheet. So that was the overall project in Ringsend. So tough journey to kind of get through the whole BIM process. It was a steep learning curve for ourselves. You can see the scale of the overall site at Ringsend. Our particular project is the structural frame building you see in the foreground of the image. So it's now part of the overall background site model on the Ringsend project. From a BIM use point of view, what did we actually use the models for in-house? We had quantity takeoffs. We use it for coordination throughout our design and our construction periods. We had health and safety uses as well. We had different risks highlighted in our BIM model. We created a couple of short 4D sequences specifically for the install of the large tank that we looked at in one of the slides earlier, how that was actually getting installed during the construction process. And then main BIM use as well at the end was the asset information. So as I said, the asset information was developed throughout the life cycle of the project and handed over to the client in the form of a data drop at the end of the project. The data drop included all our native Revit files, IFC exports, NAVIS files, both individual NWCs, and a federated NAVIS file for the overall project. Kobe output sheets were handed over, and then the Irish Water asset register was also handed over. Point cloud scanning was also part of what we did on the project. Initially scanning existing infrastructure for verification of what was there, and then also point cloud scanning what we actually built to align our as-built model with what was actually installed on site. The project itself, we created 5 separate discipline-specific models. They all had to be coordinated with 16 different background models supplied by the client. We've since created or worked on further contracts in the Ringsend treatment plant, and that resulted in the creation of another about 20 models and handed over about 2,000 assets in total, about 400 on the original project here, and then other contracts led to about another 1,500 assets that were handed over. So just from a project point of view, that's kind of what we have done in Ringsend, from kind of BIM and BIM implementation and how we're trying to improve. We're always looking at ways to improve. We've done a lot of work recently with Autodesk Inventor. Our fabrication team in-house here are using Inventor, and one of our colleagues here started looking at the coding function within Inventor to create parametric models. That coincided with the release of the Informed Design app from Autodesk. We've since done a lot of work with Autodesk in the use of that app. Basically, the app allowed the Revit end users to incorporate detailed Inventor models in the Revit project. So insert it as a Revit family, but getting a high level of detail that the fabrication guys were able to input into the model. So we looked at building parametric models with the coding, controlling the parameters within the models themselves, and incorporating specific rules and restrictions in those families. So we can see in the slide here, you know, the type of stuff that we were creating. The example is the stairs. You can see the level of detail that's in the stair tower compared to what we would get in the out-of-box Revit functionality. And we're getting this level of detail at really early stages within the project. So the second area of future innovation is intelligent P&IDs. So P&IDs are process and instrumentation diagrams. They're one of the core engineering documents that we use in the actual design of a water treatment plant. They're basically schematics that show how the overall process system works. Traditionally, this was standard 2D drawn CAD blocks, very little data behind it. So now we've gone down the route of Autodesk Plant 3D, and Harleen is going to give you a quick overview of that.
So I'm just going to talk about the P&IDs and their use within the water industry and within Murphy. So I suppose just to explain, what do we mean by P&IDs in BIM? This statement, I think, really sums it up well. So it's intelligent P&IDs. We are aiming for a high level of BIM maturity to facilitate a digital twin approach. So your 2D and 3D and data components are fully synchronized. So it's basically bridging the gap between the schematic 2Ds and 2D process drawings and the 3D intelligent models. So before I go any further, I suppose there might be people out there who are not really familiar with P&IDs. So just to give a bit on that and what role they play for us in Murphy with the water and wastewater projects that we work in. So P&IDs would be seen as the cornerstone really of all water and wastewater treatment plant design. They're a crucial part of every plant through the entire life cycle. That would be from tender design to detailed design and then onto the operation and maintenance of the plant. The P&ID itself is a simplified graphical representation of a plant and its processes, and it will show you the equipment, instrumentation, pipes, valves, etc. And it details the processes required from when raw water, would say, enters the plant until it's treated and then finally discharged. Second, yeah. So I just go on and say a bit about how traditional P&IDs were done, and what we're moving on to now is the intelligent P&IDs. So with the traditional P&IDs, I mean, all you were seeing was the plant component shown in simple 2D lines. You know, if blocks were used, they were dumb and they didn't contain any data. Whereas with the intelligent software, we use AutoCAD Plant 3D. You know, we use intelligent blocks and line types, and they can capture and embed data without adding to the visual complexity of the diagram. It's all stored in the database. With the traditional ones, obviously there was no database. And some projects could have in excess of 40 P&IDs. So you can imagine each element, valve, lines, instrumentation, all having a tag. You know, there's room for error there with simple stuff like data entry for tag numbers, etc. Because all the tags were done manually and usually recorded out with the P&IDs by maybe the process team. Whereas with the intelligent P&IDs, the databases, it's easy accessible, and outputs can be easily formatted and exported, and you'll be able to get equipment lists, instrument lists, and they can be produced at any stage of the design. And they can be used for tender purposes or operation and maintenance through the whole life cycle, basically. With the traditional P&IDs, you know, it can be quite inefficient because you're just using basic CAD, and it's, you know, it's more time consuming. You know, you could have excessive amendments due to error, and where you'd be prone to errors in data entry as well with tagging. Whereas with the intelligent P&IDs, there's increased efficiency. The P&ID allows you to create components much faster using the intelligent blocks, and you can use automatic tag generations as well. So obviously as well with the traditional dumb P&IDs, there was no intelligent coordination, where with the intelligent P&IDs, you know, you link graphical symbols to a database, and that enables, you know, data consistency. You can do automatic reporting, and you can get enhanced coordination across project life cycles. Next, please. So why did we make the change, or why should, I suppose, the industry probably make a change? We, for a designer at Murphy, we said, well, look, it would improve efficiency. The software allows for increased speed for the P&ID creation, such as dragging and dropping options, automatic tagging, breaking lines, and it's incredible the speed that you can actually turn one around in comparison to the traditional way. Data accuracy. So it enhances the accuracy and the standardization and also the consistency, because the intelligent software flags any conflicting data, say tag duplication or mismatch pipe sizes, and connections with, you know, the off-page connectors where it's going to and from. You also have then your database reporting, which is an automatic report generation, eliminates the need for you to create manual tags and reduces the data entry errors that, you know, have been historically found to add time to preparing the P&IDs. And as I said, the reports are easily accessible, and you can get them at any stage of the project once it's started. And then big benefit then here is 2D and 3D integration. So the P&ID database can be linked into the 3D models, and Murphy uses Revit to prepare all their 3D models. You know, and by doing this, then we can have a consistent approach with shared data across the models and the P&IDs. For the clients, just really what I have said there, it's like improves safety and compliance, because it's, you know, they could be used for the HAZOPs, and they identify risks earlier on, and the database can identify as well components that may be out of spec, etc. For operation and maintenance, personnel can instantly access the specifications and data facilitating maintenance and modifications when it's, you know, on site and handed over. And for handovers to the client, you know, they're receiving a structured database instead of maybe static drawings that were handed over historically, which would ease the transition from construction to operations. And then down the line, you know, it would serve for efficient maybe upgrades and retrofits, because you'd have quick and accurate identification of existing infrastructure, and making planning for expansions and retrofits, I think, more efficient. And also, we were taking it on as a company anyway for efficiency. I think it's the way forward, but in the UK now, it's actually becoming, or we've seen it as a contract requirement. So I think whether people want to make the move or not, it's going to be a requirement, which will probably soon come to Ireland as well. But it's definitely a more efficient way of working. Next, please, Mike. So what we do in Murphy, or what we're starting to do, and we have done a couple of projects already with the intelligent P&ID software. I have created a Murphy core guidance note, which is circulated, which will be circulated to all the teams. It's drafted, and the purpose of this guidance note is to ensure really that P&IDs produced in Murphy are in line with the relevant standards and specification. The document outlines those standards and specifications, includes symbols, tagging formats, etc. As Mike had mentioned, we have pipeline service colors, so these would be, you know, replicated within the P&IDs and the models, on all of the Murphy projects really. If there's any variations to anything that's in that core guidance note, it requires approval. So people can't just say they want symbols added to legends. It has to be standardized and has to be approved before implementation. Just to ensure that, you know, P&IDs are consistent and across all the Murphy Ireland projects. Obviously, there might be some change from client to client, but that will be dealt with on a case-by-case basis. So quality control as well, and change management as part of the core guidance note. We have appendices, and we have project setup forms, which are vital in the start of the project to make sure that the correct format and any existing data management they have in place is carried forward with the tagging and naming conventions, etc. Next slide, please. Oh, sorry, and then the integration, apologies. Integration there with BIM, so the 2D and the 3D integration with Revit and Plant. So PD Modeler for Revit, the tool creates an intelligent connection, I think, between the two schematics, often created with the Plant 3D, which we use, and 3D Revit MEP models. And this maps our P&ID classes to the Revit pipes and types and accessories within the 3D model. We'll also be using cloud collaboration, so that's using platforms like ACC, Autodesk Construction Cloud. So the P&ID data can be shared, reviewed and accessed, and this allows as well the 3D modelers to be able to access the schematic and check for discrepancies. And next, please.
Yeah, that's it.
One more. Oh, well, basically our objective, I think, from all of this really, as the statement had at the start, is to produce the intelligent P&IDs to achieve a high level of BIM maturity by facilitating the digital twin, where the 2D and the 3D and the data components are fully synchronized. And that's really it for the intelligent P&IDs.
Okay, thank you very much, Michael and Harleen. Very interesting. A bit of information there on how Murphys are working in the water industry. Next, we'll have Pádraig and Chris from Esri, which will give their integration perspective. So I'll hand you over to those.
Okay, first, just want to say thanks to Engineers Ireland for allowing us, giving us the opportunity to speak here today, and for everyone joining this webinar. Just to save time, I won't go too much into myself and Chris's introductions, but I'm a senior account manager for Esri Ireland with a focus on the AEC sector, and Chris is the lead business development manager for the AEC sector in Europe. So look, before we delve into this presentation, I just wanted to briefly just discuss from an Irish context as to why this is important now. So look, as we're all aware, Ireland's AEC sector is in a period of accelerated transformation, driven by the largest infrastructure investment programme in the history of the state. This also includes regulatory, reform and government and digital mandates and initiatives. And together, these initiatives are reshaping how infrastructure projects are planned, how they're procured, how they're delivered, and how they're operated, which also increases the need for better data, coordination, visibility, and decision making. And that's exactly where GIS and geospatial intelligence plays a crucial role. Our government is committing to spending over 275 billion in infrastructure related projects, and according to the Accelerating Infrastructure Report and Action Plan, they're also moving towards a digital ecosystem centered on a national infrastructure database, with GIS identified as a core platform for connecting systems, data and teams, with the overall goal to improve decision making at a national scale. And it raises an important question for everyone working in AEC in Ireland today. How ready are we to connect into an integrated digital system? And with that, I'll hand over to Chris, who will discuss how GIS supports this shift and how it integrates with BIM and the modern infrastructure delivery. And before we do that, just draw the attention to that quote there as well. That's taken from the Accelerating Infrastructure Report and Action Plan. So GIS is viewed as a key component to help accelerate this. So thank you. Over to you, Chris.
Thanks, Pádraig. And it's really interesting context, I think, because the specific mention of geographic information systems as part of this plan to accelerate the delivery of sustainable infrastructure into Ireland is really quite interesting. We've heard a lot in these webinars about BIM technology and BIM as a process. I was really pleased to hear that Marcy from MACE in the previous webinar talked about geospatial information and the integration with BIM software. It's definitely a trend that we see is on the rise. So in the next 20 minutes, I just want to explain how that's happening, why it's happening, and to give you some real world examples of where GIS is being integrated with BIM to deliver better outcomes for projects. And I guess I would always start these sorts of presentations with this idea. I hope you'll all agree with me that infrastructure assets are inherently geographic. You know, everything that you do in your work is happening in somewhere in the real world. And that infrastructure is operating across these deeply interconnected, but also deeply complex environments. I should say for the most part of this presentation, I'll be referring to BIM as BIM models and BIM software. But of course, BIM is also a process, and it's about the movement of information around the delivery of the infrastructure. So on the one hand, we have the built environment, and that, you know, the main information type for that is BIM models. On the other side, you have the natural environment, and typically the core information type of that is environmental impact assessments and environmental data. And then you have humanity and society and how we move across infrastructure and how we move across different environments. And the idea in sustainable development, of course, is that we pay equal regard for social equity, meaning access to infrastructure, to environmental stewardship, so looking after the natural landscapes, and also delivering economic resilience to our communities for future use. So if you agree with that idea that infrastructure assets are inherently geographic, then it follows that we need to be able to understand their place in the real world. And after 40 odd years of using technology to model the real world, we've still got an awful lot to do, I think, because we still don't really understand the complexity of the natural and the built world around us. And GIS, Geographic Information Systems, are designed to be one of those technologies that enables us to bring lots of different content together and analyze things and predict things and model things. So I'm going to talk a little bit about that for those of you that may not be familiar with GIS as a technology type. But the reason that it's important that we understand the real world more in more depth is it brings me to the importance of context. What we're finding with owner operators is that they're demanding more and more to understand the designs and the buildings and infrastructure in the context of their existing neighborhoods, cities, transportation networks, utility networks, and so on. So there's more of a need for us as designers and planners, even in construction methodologies, to explain where things are and how they interconnect and what the consequence of design is likely to be. So some examples here, I'm not going to go through them all, unfortunately, but traffic planners want to understand how the new bridge will work in the context of the surrounding environment and how it might impact traffic impact on a Tuesday afternoon. Maybe these things are all obvious, and I hope they are to an extent. But the point is that by bringing information together from different systems, we can help to explain our designs more easily and help them to be understood, and also transfer content across to owners and operators for operations and maintenance tasks in a way that's meaningful and easier for them to digest and easier for them to use. So all of that brings me to the movement of the information around this diagram. Perhaps you've seen some of the diagrams to try and explain how digital products and digital information products are used to help to manage infrastructure management programs, right the way from the planning and the permitting that's required for a new project through to an AC firm winning the business and then doing the design work and so on. You can see how that hopefully you can place yourself and your work around this diagram somewhere. And what we're geographers, so we're bound to say this, but what we would say is that one of the key aggregators of all of that information is location, because as I mentioned, everything is happening somewhere. So we certainly think that a location framework, a mapping framework, can be really easily used to help accelerate the movement of this information around this diagram. Because the one thing that we're running out of is time, to deliver the infrastructure of tomorrow. And by helping to make content and information more accessible and easier to understand, we can accelerate all the processes that go around it. And in that sense, we think there's opportunity everywhere for digital transformation. But there's this great quote from Gartner, so I don't want you to just take it from Chris, the geographer, that they also believe that location and an understanding of location is critical to successful delivery of infrastructure and of collaboration as well. And they summarize it by saying this, that everything that an organization does is in one way or another associated with a location. So what then is a geographic information system? And it is a technology system. I'm sure many of you will have heard the words, but perhaps not understood quite the depth that it goes into. It's founded on this idea that we're trying to abstract the real world into a digital model. So it's been said of GIS professionals that they've been creating digital twins for the last 40 years because all of their work has been about abstracting the real world down into maps and information products to understand what's going on. So it relies upon this core ability to project the real world into a digital format. And for that, we use different types of coordinate systems. But then on top of that, you have all sorts of tools and all sorts of processes and services that can enable you to bring information in from all sorts of different places, different systems, and analyze content and overlay content and provide meaningful reports and predictions about things. So, an illustration of that is all of the sorts of information types that you likely use on all of the project work that you do in your project delivery. Everything from background environmental data, transportation networks, and human movement data, through to real-time sensors, to CAD and BIM models that have been talked about a lot, and also the imagery content that's been mentioned in other presentations, coming from remote sense satellites or from drones, even data that's collected in the field using mobile phones and tablets. Because of that location component, we can integrate all of that content together. But it doesn't stop there, because what also is very obvious is that much of your other enterprise systems contains data and information points that are relevant to project delivery. So again, if we can use the connection of location to integrate that content together, then it gives us a much more holistic view of how the design or how the individual building components might work together. And something that we've been in the process of doing is working with lots of these other enterprise grade technology platforms to make sure that we can integrate the content together, and we can therefore make sense of it and share it and collaborate with it. But this idea of asking where, and the idea that it accelerates business insight is going way beyond just putting things onto a map. And that's why we take the time to explain about the geospatial technology, because it's too easy to think that, oh, if I put my BIM model on a map, then that's my GIS. Well, no, that's not as deep as you can go. Yes, certainly placing things on maps helps you to understand where they are and their connectivity. But beyond that, we can start to measure things like the size and shape and distribution of things. So where are all of my stockpiles? How soon do I need to replenish them? What's happening to all of the waste that's coming off the site? Where is it all going? How can we optimize that, and how can we change our business practices? We can determine relationships between things. So how does the incoming weather, impact my concrete offsetting time? Now, many construction professionals will do that, natively. They understand time dimension, but it's important to be able to model these things to determine those relationships. We can evaluate the best locations for things and setting down temporary buildings so that they don't interrupt buried utility networks, for example, which we've seen happen in the past. We can detect quantity and quantify patterns in our data. Why is it that certain projects always run late? Why is it that I'm always overstocked on particular materials of different types? And then at the end, get to the modeling and prediction of, well, what about rehearsing the entire build, using the maps and the GIS content as a means of illustrating how this thing can come together? But far and away, what we've seen is that the biggest opportunity for digital transformation is this integration directly between BIM technology and GIS technology. And as you all know, the BIM technology is all about the very, very detailed drawings and diagrams and models that describe the built feature. The GIS provides much more context and much more related features, so geology, weather, time, and so on. Maybe even buried utility content, network management content. And the idea is to integrate all of this stuff together. And when we do, we can start to truly deliver on the idea of an integrated digital twin. So this is just running in a simple web browser, and it shows the amount of content that you can now stream natively from web technologies. And you can see the context here is the city scale of Zurich. So we're not even confined just to the individual building or infrastructure asset. We can take into account all of the surrounding neighborhood and run the analysis within this same platform. So this is not just fancy graphics software or media production software. This is a real interrogatable system that enables you to dive into the content. In this example, adjusting the reality mesh to remove the existing facade to show how the BIM model will look when it's been replaced. So we can integrate all of this content together and thereby derive more intelligence and create plans of action and get to work. And this is being proven. As I said, I'm going to finish with some case studies, but I want to draw your attention to this report from the geospatial world. It's being recognized by owners and operators, by government, and by AEC firms that the integration of GIS and BIM is bringing more value to the overall process of infrastructure management. It's massively reducing the amount of information that's lost as documentation is passed from one phase to the next or one stakeholder to the next. And it's contributing to a reduction in rework. So we can field validate, inspection chambers to make sure that they've all been captured, so we don't put foundations in the wrong place and so on. So it's about releasing professionals to do the important and valuable work rather than just dealing with the issue of where is the data and how do we know that it's accurate. And hopefully some of the statistics across the bottom here will speak for themselves. And you'll see this actually in some of in the documentation that Porrick mentioned earlier on. Many clients are now requiring the delivery of BIM models to integrate with the GIS content that they use to operate and maintain their asset. It's much more widely used technology, GIS, within the owner-operator space. And now what we're seeing is that AEC firms themselves are starting to acknowledge that GIS data, even just the data itself, not least the analysis, is important to their daily work because it's helping them with context and helping them to understand what's going to make a meaningful design. And as you move into project delivery, then again, these statistics are quite compelling, I think, that you can save an average design time of 28%. And 13%. Who wouldn't want to save time or money on a project? And that is the point of the application of technology. Easy wins to get started. If you haven't thought about this, it's possible that for some of you, you have a GIS team in your organization. They may not be well known to you, but we tend to find that these GIS capabilities start in the environmental space because there's a natural tendency to use mapping for ecological or habitat mapping. But what we're seeing is that on the left-hand side, the design teams that are using all of the BIM modeling software, many of which have been mentioned already today, are now able to bring the GIS data into that design environment to immediately start to give better context to their design plans. And this can become a two-way thing. So at the same time, the GIS teams who might be doing the buried utility modeling or even the landscape modeling can start to bring in the CAD and the BIM content to help them with the more, the faster iteration of the right design to get to the end. And I guess bridging that is the use of all of that information through the language of maps, or the idea of this portal through which you can get to different types of information are the project teams who are able to make business decisions and on-site decisions by using the information from both the CAD and BIM data, the GIS data, in fact, any attribute information that can be brought to a single location to help get the job done. And that's both from browser applications, but also in the field. So we're seeing this happen in lots of different ways for lots of different project stages. So I'd like to just end with 6 different case studies from customers that are, some of them are quite mature in their use of GIS, but others are just starting down this process. So I want to make sure you understand that the use of GIS and BIM integration can start really, really quickly and really easily. And from then, we've seen some very elegant and yet complex solutions being used to deliver the digital content to the client for handover. And it goes all the way through. So this is at the very early stages. So Hauser Levine use the GIS to create incredible visualizations using Unreal Engine for explaining to clients and to citizens different options for new buildings in neighborhoods. So it's enabling that more digital interactive experience that people do in their everyday lives with gaming and other things. but it's enabling people to really understand what the design could look like, and then to be able to comment on it and see it almost in near real time, to see how their experience will change of using their home environment or their neighborhood. The other thing is that it's helping House of Living win work. So by adopting this sort of technology, they're finding that it's demonstrating innovation to their clients, which the clients want to buy into. So it's enabling them to outpace their own competition, to win more work using this innovative way of explaining the design. Over in Norway at Multiconsult, they're using the GIS and the BIM content to do that very early conflict analysis and enable better understanding by all the project stakeholders of what actually, in this example, what actually is this intersection going to end up looking like? How will it impact the natural environment? What's the cut and fill volumetrics? And yes, you could say that you can do a lot of this within BIM technology, but I hope you'd agree also that there's often multiple models coming from multiple systems. And as long as we can tie everything back to that location, then we've got a chance of actually understanding all of those models together and creating a truly collaborative design environment. And that's what's going on at HDR. This is the Ontario Line project. So it's 15 transit stations, 10 miles of track and so on. But what they've built is a portal through which they can access all of the BIM models, all of the content. And by the way, it's worth saying, our design philosophy around these sorts of platforms is that the content should sit in its system of rest. So we believe in connected digital twins or an ecosystem of CDEs, not just one CDE to rule them all, but keeping the content where it should be for updates and for management, but being able to go grab it when you need it to integrate to get to the information that you need. So this portal had a huge impact within HDR. Thousands of staff using it, and as a way of really just finding the information that they need when they need it. TPF, on the other hand, taking this into the fifth dimension. Why not? So we've got the time element here, but also project costing. So being able to visualize the build of a stadium here, to track the progress of it, to track the scheduling of it, to make sure that materials are being delivered on time and so on. But by bringing the BIM models in with the GIS analysis, enables that much broader understanding of what's going on in the entire site. HMTB using real-time sensors. So in this example, this was a bridge redevelopment program. They're actually building a new bridge very close to an existing historic bridge that had various protection orders on it. So they were using IoT sensors to measure vibration and measure temperature and so on, but also being able to dive directly into the BIM models to make sure that everything was going to be connected and working well. And finally, for operations and maintenance, FS Technology over in Italy now use the GIS and the BIM content together for managing their entire network of railway lines and stations. And you can see on the screen there, 40% time saved by getting rid of those repetitive tasks, moving more into automation, but also reducing the number of health and safety incidents that they have, because people are better prepared when they go on site, and the health and safety managers can see where all of the issues and risks are. So with that, I think I'm just about at time, Joe. I hope that's been okay. That's 20 minutes on GIS and BIM integration, and of course Porrick and I are around and our details are on the screen if you'd like to learn more about it. Thanks, Joe.
Perfect. Thank you, Chris and Porrick. That was really interesting. And I have a question later on, which I'll keep for a few minutes.
Sure.
So finally, we hand over to Emma, who will give some information on future training.
Great. Thanks very much for the introduction, Joe, and thanks to Jancy for inviting me to speak today. I can't actually share my screen until Chris stopped sharing his screen. So if Chris could do that. Great, thank you.
Sorry about that.
That's all right. Thanks, Chris. So as I said, thank you for the introductions. I think the stage of me discussing digital construction and upskilling in the BIM environment is very appropriate after those really great presentations from Michael and Harleen and Pork and Chris. Hopefully there'll be some information from this presentation on how to upskill to be able to engage in the processes that the previous speakers were talking about. So I'm a full-time lecturer in Technological University Dublin. I'm based in the School of Surveying and Construction Innovation, and that school really speaks to what the previous speakers were talking about in terms of upskilling the industry. So we have teaching, research, and professionally active in the areas of geographic science, geomatics, quantity surveying, real estate, construction management, and digital construction, which is what my wheelhouse is. We're long established and the best educators of surveying professionals in Ireland, and we educate students to the standards that are required for professional bodies. And some of the recognition we've got is from the CIOB and the SCIS. TU Dublin has always been about making graduates industry ready, so students get practical hands-on education using the top of the range IT and surveying equipment. I'll give a very brief overview of some of the programs that we offer in relation to digital construction and BIM in the construction industry. So the first one is we have a Master's in Applied BIM Management, and we're just going through a major program amendment validation process at the moment to be able to offer this as a 1-year full-time MSc and also as a 2-year part-time. Previously, for the last 12 years, we've been offering it as a 2.5-year part-time master's. So going through the program, after 2 years part-time or 1 year full-time, you graduate with an MSc in Applied BIM Management. But there are also points where you can exit with a postgrad cert in BIM Technologies and a postgrad diploma in Collaborative BIM. As I said, we're hoping to be able to offer this full 1 year full-time in September, and also the reduced 2-year part-time offer. It's a blended learning environment. So we have, flexible student-centered learning. So we have on-campus workshops along with online sessions, and then asynchronous self-paced sessions as well. And we have the latest technology when it comes to the virtual learning and teaching environment. We use real-world digital construction tools. So we're supported by Autodesk with the use of Autodesk Construction Cloud, Revit and Navisworks, and we also have other arrangements with other software providers as well to provide software for the students. We flipped classrooms as well, which gives the opportunity for self-paced learning, and it's all delivered through our integrated support and digital learning ecosystem. So just to talk about the MSc and how it breaks down. So in year 1, you can exit with a postgrad certificate in BIM Technologies, part-time. Year 2, part-time, you can exit with a postgrad diploma in Collaborative BIM, and I'll talk a little bit about that in a second. And then after year 2, part-time or 1 year full-time, you can exit with an MSc in Applied BIM Management. So the MSc in Applied BIM Management looks at BIM technologies, AI and data analytics in the first year of the part-time program or the first part of the full-time program. And there are various different modules associated with that. So from the technology side, so advanced BIM for architecture, mechanical, electrical, surveying, construction management. And then we go deeper into those technologies with sustainable and digital design, energy analysis, performance and AI-driven design, and advanced workflows for construction and cost management. We also start to bring in modules that kind of support the overall digital construction process, so scan to BIM, programming for engineering and the built environment, data analytics for engineering and the built environment, and then also visual programming as well. So that students can do those modules and exit with a postgrad cert at the end of that. Then in year 2 of the part-time masters, or the second part of the full-time masters, we look at multidisciplinary collaboration. And as Michael and Chris have mentioned already, BIM and digital construction is a process. So the multidisciplinary collaboration looks at the process around project delivery. So we have a multidisciplinary collaboration project where students get to implement ISO 19650 BIM processes and workflows in a project and a real authentic real life project based environment. There's also the collaborative BIM process where students really deep dive into ISO 19650 and how to implement them for any procurement methodology right through the life cycle of a project. We also introduce Lean and BIM and the integration of those two methodologies, along with entrepreneurial skills for digital construction, and then digital construction technologies for modern methods of construction. And then finally, the last part of the Masters is a capstone research project. So students get the opportunity to delve into a topic that is relevant to them and what they do in industry, or to address a problem statement that they've seen from industry. So they produce a capstone research project. And I suppose the graduates, and we've seen evidence of graduates and where they've excelled in the industry. So the graduates come out with advanced BIM and digital construction expertise. They have a collaborative and multidisciplinary project leadership, strategic problem solving and innovation, and professional competence, ethical awareness, and lifelong learning. And also they've through the program, they apply research and digital innovation, and they bring that to the workplace. In terms of industry demand for graduates from the program, so there's a skill shortage that has identified BIM roles such as BIM managers, information managers, and I suppose just to kind of expand on the whole information manager side of things, with the Capital Works Management Framework BIM mandate, there's obviously a huge demand now for information managers to comply with ISO 19650 information management standards. There's demand for BIM coordinators, BIM technicians, and this was all highlighted in the Build 2024 report, and further the Sullus Vacancy Survey report. So there's lots of evidence of a skill shortage in the area of BIM roles and BIM expertise. As I mentioned, BIM is now mandatory for the public sector, and obviously that as policy change significantly increases the demand for qualified BIM professionals. And I suppose there will be people at the webinar today who maybe don't want to commit to a 2-year part-time masters, or may not want to commit to a full-time masters. And there are other digital construction programs within the School of Surveying and Construction Innovation. So we have a 1-year part-time BSc in digital construction, which touches on a lot of the subject matter that I've spoken about in the Masters, but it's delivered at level 8 qualification over 1 year part-time. There's contact details there if anybody is interested in finding out more about the BSc in digital construction. We also have a digital construction and engineering analytics part-time course, again, which might be of interest to those of you who are interested in data and data capture and data mining. And again, there's details there to if you're interested in contacting the program chair about that. It's a 1 year part-time program as well. It's been a very brief overview of what we deliver in terms of digital construction in TU Dublin. If you do want to know more about any of the courses that I've mentioned, there's YouTube video links in the slides that I presented today, so you can delve in further. And there's also contact details for the program chairs. They would be happy to discuss any of the courses in more detail with you. So thank you all very much for your time, and I hope there's something of interest for you there.
2 o'clock, so I think we call it a day there. That was a really interesting set of presentations, and thank you for all the speakers again, and all the speakers who have contributed the other 3 days. We've had over 1,500 people attend these over that period, so it's been hugely successful and just shows the interest in this area, and probably shows maybe that there's a lot more training is needed in this area, which is probably Emma's opportunity. But thank you all for joining us today, and keep an eye out for future presentations that the Civil Division is running through Engineers Ireland. So thank you, and have a good rest of your day.